Hi, I'm meteorologist Julie Packett.
And I'm meteorologist Frank Alzheimer.
At the National Weather Service, we're charged with the responsibility of making life-saving forecasts and warnings for the people of southern South Carolina and southeast Georgia.
But before we can make an accurate prediction of the future, we need to know what's going on in the atmosphere and the oceans right now.
We rely on a number of data sources and observations that range from 25,000 miles above the surface to hundreds of feet below the water.
In this video, we'll briefly introduce you to some of the observing platforms that we use on a daily basis. To start, we're going to look at the observations furthest away from the surface of the Earth, satellites.
There are two types of satellites that are used by forecasters in the National Weather Service. The first are geostationary satellites, which move in tandem with a rotating Earth, so they are always located over the same fixed spot. The second are polar orbiting satellites, which orbit the Earth in a circle route over the poles. Geostationary satellites are excellent for showing the atmosphere in motion as they take images as often as every 6 minutes. On polar orbiting satellites, however, many of the sensors have much higher spatial resolution, allowing forecasters to see more details in the clouds. Another source of remotely sensed data is Doppler radar. The radars collect data throughout a large volume of the atmosphere every 4 to 6 minutes in active weather. Radar data aids in estimation of rainfall amounts to help predict flash flooding. Radar information is also critical to the severe weather warning program as it helps forecasters see inside building thunderstorms to check for signs of hail, strong winds, and rotation that can mean tornadoes. One other source of data in the sky is airplanes. Some are designed specifically to fly into storms, such as hurricanes, to collect and disseminate lots of critical weather data. Surface observations are imperative to forecasters in the National Weather Service. A wide range of weather instruments are used to enhance the precision and timeliness of forecast, watches, and warnings. Among the most utilized meteorological observing equipment is the Automated Surface Observing System, or ASOS. ASOS obtains an extensive variety of continuous meteorological observations which are transmitted as a coded message. These messages contain sky conditions, surface pressure, precipitation, temperature, and wind parameters, among others. With over 900 ASOSs across the country, this dense surface data can be plotted onto weather maps, allowing meteorologists to see important weather patterns. There are several volunteer programs where trained volunteers can contribute by submitting weather observations. They can use simple meteorological instruments or report severe weather in real time. Two such programs are the Skywarn Storm Spotter program and the Community Collaborative Rain, Hail, and Snow Network, known as CoCoRaHS.
Here at the National Weather Service, we take daily rainfall observations, just like the volunteers of the CoCoRaHS program. This is an 8-inch standard rain gauge. In all, it's made up of 3 main components. We have our removable funnel, the inner tube, which collects up to 2 inches of rainwater, and then the outer cylinder, which will collect any overflow.
In contrast, for every 100 observations over land, there is only about 1 observation at sea. Few sea buoys, limited tide gauges, and a handful of boater reports make up the bulk of marine observations that forecasters use routinely. We do have one instrument that will give us data from the ground to 20 miles into the atmosphere. That instrument is a radiosonde. They measure temperature, relative humidity, and pressure. Twice a day, simultaneously all over the world, radiosondes are attached to either a helium or hydrogen-filled weather balloon and released into the atmosphere. In order to obtain the most accurate data, the radiosonde is calibrated to reflect current surface parameters. In addition, a small parachute is attached to the balloon and radiosonde to complete the upper air sensor unit.
So after a successful release, we'll come back inside and ensure that the software automatically detected the release. We'll also ensure that the signal strength is strong and we're getting a continuous flow of high quality data. Then after that, we'll make any changes that we deem necessary.
As the instrument is carried aloft, temperature, relative humidity, and pressure data is transmitted back to the office and available in near real time. In addition, GPS is able to track the exact position of the radiosonde, therefore allowing both wind speed and direction to be obtained. With increasing height, decreasing pressure allows the balloon to continuously expand. Eventually, the balloon reaches its elastic limits and burst, ending the flight and allowing the radiosonde and parachute to slowly descend back to the surface. This critical data gets ingested into weather models, providing improved forecast. Upper air data can also be plotted on a weather map, giving meteorologists an even more in-depth look at the overall weather pattern.
In this video, we have shown you a number of ways we observe conditions in the atmosphere, on the ground, and in the oceans, all of which are critical for creating meteorological products.
From multi-million-dollar satellite platforms down to volunteer observers, everything and everyone plays a role in ensuring the most accurate forecasts and warnings possible are issued by the National Weather Service to protect lives and property.
Thank you for joining us. Have a great day.